So, okay, I want to continue study general ability following the Carrol's book around 106 pages. Okay. This process in a product to parameters vector is preserved. D lambda and G mu V mu D lambda D mu V mu Z mu D lambda G mu V mu D lambda V W mu equal, and this part equal 0 because the external derivative what's imply exactly covariant derivative is compatible with G, so this is equals 0, and D lambda T is D lambda V lambda is also G sigma T this is relative with parallel transport OID they are compatible with and direction covariant derivative D mu there V is transported along with x lambda curve x, so this part equals 0, so this is 0, so this means the parallel transport is not a compatible connection preserves the norm of vectors. Preserve the norm of vectors. With parallel transport defined, the next logical step is discuss geodesic. Geodesic curve space generation in Euclid's. We all know what straying is. We have a short distance between 2 points, but there is equally good definition. A straight line is a path parallel transport its own tangent vector. It will turn out these two concepts coincide if one this connection is a cross connection. We start the second definition. Geodesic is a curve along with tangent vector is since it's a computation much more straightforward. The tangent vector to path x, the condition that is parallel transport is thus d lambda and dx mu d lambda. And dx lambda 0 and d lambda equal d lambda dx delta x new, so x mu, so Yeah, equivalently we write dx rho dx lambda d lambda dx sigma. So geodesic equation. And you should remember, we can easily see it represents user notions like the correct equal space. In the case, we can choose class in which this equation is just which is the equation for a straight line. That was emphasizing simple. Let's turn to the more general case of the short distance difference. As we know, subtree involved in the definition of distance in Lorentz space. For neural path, the distance in the for time path is more convenient to use the proper time. So is the name simple. Let's do the calculation just for the equation. Good for input. So we are not using engine. We therefore consider the proper time fraction. This is proper time. Well, what's mean? This is invariant and any transformation. Proper time, and this is a time you explain at rest time, at rest frame. For example, something move in time space. If you lie on such ball, you can feel this time. Okay, whether interval is over the path to set for shorter distance, but we could do the usual calculus variance treatment to see critical points of this function. They will turn to we have the maximum proper time consistent with our discussion of the twin paradox. However, we can simplify the algebra by means of the integral 3.45 is of the form f is a function which is dependent on the path lambda. Lambda t. I don't know the parameterization. The values look like delta tau, delta minus f tau d lambda minus f. F is f. Okay, this is the definition. So the variation looks like variation looks like act on like normal derivation, normal differentiation on one variable. But I think you should check. You should check the regular logic. In the case of variation, variating the path. Okay, so it makes things easier if now specify our parameter is proper time itself rather than the arbitrary parameter lambda. So the tangent is a 4 vector u mu. This fixes the value of f z mu dx mu d lambda d tau dx mu z mu u mu u nu equal 1 Yeah, because this is a proper time I can choose so that f equal minus 1. So from this we then have delta tau and minus 1 divided to delta f d tau. Stationary points of this pass for which delta tau 0, therefore equivalent to the station points with a fixed permutation of the simple integral. I equal delta f d tau equal fz mu dx mu tau dx tau. The is by no means necessary, but will make things nicer later on. Taking branch of this extreme is thus a shortcut to find shortest distance path, one that we will rather for. Station points over I will of course obey the I will equation, but if there just as a simple direct constant the tend to integral point to the plus so x mu plus delta x mu and z mu equal z mu plus delta sigma z mu delta x sigma. This is okay. It's okay. You can, or I may check later on. The second line comes from Taylor expansion ring, which, as you can see, use a particular node covering. This is because we are simply changing or component as a functional space in some space coordinate space. This into super keeping one times faster down. We get so delta I delta equal delta sigma. Well, of course, derivation. Blah blah blah. Yeah, you can. Since we separate for station point, we want data to branch for and branch. This implies the music. We can that this is a process that this equation. The x or the tau geodesic equation. But with a specific charge that's a extremer of the length function curves are private transport there. It doesn't matter if any of the question is defined of course. Is only used so the two notion as the variation possibility to enter the question for geometry rather than simple. It's often less work to explore. Property of geodesic. The primary use for the primary is for in general is they so the perspective this particle is body that doesn't its influence through its different practice, but from this control the property of the star was worrying about the Function can be thought of as generation neutral life. For the case, to the curve. It's also possible to introduce force by adding a term to the right one. Looking back to the expression, mu rho sigma, dx rho, dx tau, dx equal mq f mu tau dx mu. Why I can't tell. We will talk about this more later, but in fact, you guess would be correct. Looking back to the expression. This is something. This is Friday power. No, I think Friday power. So, or something potential. No, more potential. I think potential power is a different form. Say some more careful about the parameter of those. When we present the Zeus equation as a requirement that the tangent vector be prior transported 3.44, we parameterize our path with some parameter lambda, whereas when we found the formula for that, we wouldn't up with a very specific parameter. The parameter, of course, from it's a correct transformation. First, I'm going to leave the equation prime. Any parameter related to the parameter in this y is called the affine parameter. Just go at the proper time. What was hidden in the tangent vector before transport actually? The special to run related to them. If you start at some point and with some and then construct the curve by beginning to work background, you will not only define path in, but also define the parameter on the path. And there's nothing to stop you from using any other parameter, like but then will not be sure. More general, you will satisfy it. Okay, so it's f alpha dx mu d alpha. We rename tau as the new parameterization alpha because tau equal lambda plus a tau plus b. Where f alpha is related to the affine parameter by y f alpha is the alpha d lambda zero d alpha d lambda. Yeah. Conversely, if 3 point is satisfied along curves, you can always find the affine parameter lambda alpha for which the equation will be satisfied. Affine parameter. We can write the equation in terms of the u lambda d lambda u mu. Similar in terms of flow moment p mu. The equation simply p mu 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 p lambda d lambda p mu. but we can write this equation in terms. Yeah. This relation explains the idea of a free-flowing particle keep moving in the direction if their moment are pointing. For neural paths, the proper time branch at tau is not the property of parameter. It is perfectly defined to ask whether parameter satisfies the neural path is disk for some parameter lambda, equally for any other parameter. However, there is no preferred choice among these parameters, like the proper time is for time-like path. Once we choose a parameter somewhere along the path, of course, there is unique to the rest of the path if we want to solve the it's often convenient to choose a normalization of parameter along the neural is equal to the momentum vector. This is equal to time-like path. The x mu delta is a momentum per unit mass. Then an observer with measured the energy particle or equal to the frequency, since we are setting its per equal 1 to be p mu u mu p mu u mu dx mu dx lambda dx mu dx tau. This equation always tells us energy of a particle with as measured by observer with for velocity u mu is null or time-like. You can check it by going to local initial coordinate curve. This question for it does not include the potential or is introduced from motion in nature in general. There will be a right defined notion of gravity potential and also its special case. Input property of the input with rods metal is that the character of the relativity metal compatible connection never change. This is simply because the prior transport of the inner product and the character is derived by the inner product of tangible weights. This is why we are constantly doing the term. When we wrote for space-time like paths, we would have derived the same equation since they are different with signs. Let's now explain our remarks timeline. The reason we know this is true. But we're going to do. As we increase the number of chapters, the neural curve come closer and closer to the have their paths. Time like those cannot therefore be curved for minimal proper time. The rodent. The great circle figure. We can always observe the time like path by a sequence of neural paths with a total path. Time like path sequence of neural paths with a total path length of the hence. Time like this must be maximal over the proper time rather than we can always observe time like path. Oh yeah. So yeah. Unless we can draw a great cycle through any turbines and the method traveling between the short way or the long way along. One of these is always longer than the other, although both saturation points of the length structure. The disk provides convenient way of mapping the tangent space point to the measures called the exponential map. This map is a time-defined set of coordinates for this region that are automatically the local initial coordinates disk. Coordinates around the point P such as the exponential map. G mu nu P delta sigma z mu p 0. I can look in but what is this? Gamma rho sigma mu equals 0? I think for all sigma mu rho, so gamma crucifier is also 0. I think this is a equal condition, equivalent condition. I think yes. So, through definition of equation, we begin by noting the n vector k different unique zeros pass through it for which k is a tiny vector to be lambda p equals 0 dx mu k mu k mu unique zeros pass through it for I think k mu lambda equals 0. Unique from the fact that it's going to the different regions specifying initial data in the form of xp k mu completely determine a solution. On this, there will be a unique point. The external map at p xp defined x mu lambda 1. I think t equals 0 to t equals 1 at time t at lambda 1 x mu here. I think here exponent p k here. Yeah. For some set of tangent vector k mu near the vector, this map will invertible depending on the near the zero vector. What do you mean? Near depending on the geometry, however, different geometry emanating from a single point may eventually cross, and with different geometry emanating from a single point may eventually. At which point is no longer bounded. Furthermore, the length of exponent is not necessarily the whole manifold, and the range is necessarily the whole tangent space. The range can fail to be all of M simply because there can 2 points that are not connected by any geodesy. An example is given by anti-do theta space discussed in chapter 8. The domain can fail to be all of TP because this may run into singularity, which we think of as the edge of manifold. Manifold that have such things are known as geodesic incorporated. Geodesic incorporated. In a more careful discussion, each structure will be the external map take a vector to be two points that lie at the unit of parameter along the x2 with the vector. As a right, the best way we have a defining singularity is the terrain. After we remove trivial case with part of the mind excluded by several double hawking glass. This problem. The synchrone Hawking parallel says that for certain matter contents, spectrum in general they are almost guaranteed to be geodesic. As an example, two of most short solution describe black hole and the Friedman-Lorenz-Morka describe homogeneous in isochrone both feature important singularities. These will be discussed in later chapter. We now use the exponent map to construct local inertial frame. The essay practice to find the base vector local instrument, such a mu base vector mu hat in TP problematic with a canonical form such a component the mu g e here the delta method sort of multi-linear map from TP to that has have a different meaning. Over E, they remind us it's a base vector, and over they remind us we are in local initial coordinate. This is easy because it's just linear and not yet reference coordinates starting with any set of components. We can always diagram this matrix and rescale our base vector. The hard part we would ask is finding a coordinate system x mu for which the base comprise the coordinate basis e mu equal delta partial derivative mu, such that the first partial derivative will vanish. Yeah, partial. Yeah, there. In fact, external map achieves this automatically for any point Q such that to be unique delta path connecting P to Q and unique parameter lambda such as lambda P and lambda Q. At P, the tangent vector K to this student can be written as linear combination of our base K mu E mu. We define the sort after simply to be this coordinate x mu k mu. In other words, we have defined a coordinate x mu to the component with respect to of tangent vector k get back to q by x. Coordinate to contract in this way, we are Riemann normal coordinate. So I think this is e mu k e mu k. So this is a Riemann normal coordinate. This is tangent vector k. We still need to verify that these Riemann normal coordinates such way. Know that ray in the tangent. So can I take a rest? I want to take a rest.